So, hello everyone. Thanks for joining. So I hope you're here to either learn a bit more about creating continuous delivery pipelines or to see me suffer for 45 minutes trying to build one. Otherwise, you can still run away quickly. So let's quickly start. Some information about me. So my name is Johan Janssen. I work for a company called Infospoort, which is located in the Netherlands. So I have no direct relation with the tools that I'm using. So it's not something I try to sell you. It's just that I like using them. If you have any questions, also feel free to email me or tweet me about it. So what are we going to do? I first explain a little bit on why you should want continuous delivery. Then I have to work hard and you can sit back and relax. And then we have conclusion and questions. If you have small questions in between, feel free to ask them. If you want to discuss something, then I prefer to do it at the end or after the session because I have only 45 minutes. So to begin, back in the days, we all had waterfall. And after a while, we decided basically to do agile. At least most companies nowadays work in some agile way. So we create small changes instead of big changes. The only problem is then after you created those small changes, what I noticed in a lot of companies is that they still end up somewhere on a shelf. And there are a few problems when your new features, if it's a car or software, it doesn't really matter if they're laying on a shelf. First problem is you don't make money of it yet. Second problem is you don't have happy customers yet because they cannot use your features yet. And so basically agile is a nice first step. Next step is basically to do continuous delivery and basically improve upon it and make sure that if you build something new, it's available for customers. For me, something is really, a feature is done if a customer is actively using it. Else it's still a waste of time. So to get our hands dirty, what are we going to do? Basically, we as happy developers are over here. And we are going to create some automated pipeline to deploy our applications to the happy end users. In my case, so I will give you a link to the steps that I'm following. I made some instructions which I will follow as well, so I don't have to remind everything and have to type it myself. And in those instructions and scripts, I make use of some things because at conferences often the network is quite bad or it's even gone. So basically I do everything offline. And to do that, I store all the Docker images on my laptop. I stored all the Maven dependencies that I have for my Java projects on my laptop. And for the OWASP dependency check, which checks the vulnerabilities of your Maven dependencies on, basically known vulnerabilities. And therefore they use big reports, which is like 1.5 gigabytes of downloading. I store them as well. If you follow these scripts on your own environment, you might choose to remove this and download it live continuously, so you have the latest information available. But for now, I cached these things. So my entire setup is running on Docker, Docker Compose, in fact. And I'm not going to dive too deep into Docker because it would cover the 45 minutes easily. There's just one thing to note because it's coming back in the scripts. That is, if you go to a Docker container within a Docker Compose network, if you go from your host to one of the containers in the Docker Compose network, you have to use localhost and the so-called external port of the Docker container. If I'm within the Docker Compose network, so both Jenkins and SonarQube are running within Docker Compose, then I can use the name of the service and the internal port of the service. So there's a small difference there. So what I'm going to do is I go from my typewriter to my Docker Compose network. So everything is running in this Docker Compose network. And in between this network, I can easily use the names of the applications instead of having to use an IP address or something else. If you missed some pictures, I will publish the slides later as well. So feel free to take pictures, but don't worry if you missed something. So basically what we're going to do is these steps. We're going to push our code to GitLab. Then GitLab will automatically trigger Jenkins. Jenkins will start compiling, testing stuff. And then we will do some automated quality checks with SonarQube. Afterwards, we store our artifact, a jar file in this case, in the Nexus artifact repository. After that, I will create a Docker image, publish the Docker image to a Docker registry. So Docker registry is like a Git server, but then for Docker images. And after that, I will use that image to start a running container with my application inside it. In my case, it's a Spring application using Tomcat. But I could use basically anything. And after the Micronaut presentation this morning, I'm convinced that I have to rebuild it in Micronaut. So maybe next time I will use that. After the application is deployed, I use Gatling as a performance test tool to test the performance of my application. So this is an example setup for a continuous delivery pipeline. So yeah, let's start building. So first, so basically what I did is I removed everything except the stuff that I said that was cached. So I have a clear environment, and I use this Docker Compose file to start up all my services. So for instance, GitLab, Jenkins, SonarQube, everything is in here, and that's automatically started. I already did that because it takes a little while to initialize GitLab and everything. So it's up and running now, and we're going to use that to build our stuff on top of it. And so these are the instructions, basically. Oh, wait. These are the instructions, and I will later share the link to GitLab where you can find them. And so I already did some of the configuration parts, like making sure that Docker can use enough memory and enough CPU power, and the Docker containers are started. I configured my Nexus cache in my settings.xml, and I'm now up to creating a Spring REST application. Just as an example of an application, doesn't really matter. You could use any framework for this to build your own application. So we'll start by creating a simple greeting class. And a greeting controller. And we can run this application, of course. Simply run application. And then it should start. And so I have my really advanced application, which is displaying hello world, or in this case, hello Johan. And it counts how many calls I've done to the application. So nothing really spectacular here, just a normal Java application. And so we'll go to the next part. That's to create a project in GitLab. So in GitLab, we will create a project for our source code. Who of you are using a Git server? Yes? OK, cool. You should. I still remember the days when I didn't have version control and we simply overwrote each other's files. Really annoying. So we create a project, give it a name, in this case simply test application. We make it public because everybody is allowed to use it. We create the project, and then we get some nice instructions. And as I already have some source code, I use the instructions for the existing folder and simply copy them into my project. So let's see. Copy them in here. So now if I go back, I should have my source code within GitLab. Yes, it's there. So on to the next step. That's to configure Jenkins. First time you configure Jenkins, it has like an automatically generated password. So I have to retrieve that password to make sure that I can start working with Jenkins. So I simply, oh wait, missed a copy here. I simply use this command, which uses Docker underwater to retrieve my initial password. And I can use that to log into the Jenkins interface. Continue. Don't want to save it because it's a one-time password and it's way too complicated. So first thing we're going to do is change the default password to something which is more manageable. Now it takes a little while because it's trying to make an internet connection, which isn't there. And afterwards we can simply continue. So it will time out after, I don't know exactly how many seconds, but then we're good to go. So now we're good to go. I skipped the plugin installation because I did that automatically in the Docker setup. And we simply say continue as admin, not now, start using Jenkins. So first thing we do is change the password to something really secure, like admin, because else I cannot remember it. And so the next thing we are going to do is we are going to add Java 11 as a JDK, because by default Jenkins is running on Java 8. And the Java 11 build of Jenkins at the time that I tried it wasn't working with the continuous delivery pipelines that I use. So I installed Java 11 next to Java 8 so I can run my own applications against Java 11 while Jenkins is running on Java 8. And to do that, I can simply add that in the Manage Jenkins section and then global tool configuration. So I say add JDK, Java 11, with the specified version. I also configure Maven because else it will download it and I don't want that. And I already installed it based on the Docker file. So I can save this. And one last thing I'm going to configure here is for the security I'm going to disable some checks. So I'm going to disable cross-site request forgery exploits. So I don't care about security for now. I still think security is important. So if you implement this, you probably want to add like SSL, certificate-based solutions or other solutions to make it more secure. But you can add that later. And for now, it saves me a lot of time so I can manage my presentation in time. So now we've configured Jenkins. Next step we are going to do is use a Jenkins file basically. So if we look at the setup, we've configured this, we configured Jenkins a bit, and now we want to create a Jenkins file which specifies what Jenkins will do based on my code. So after I do a new commit and push of my code, Jenkins will have to execute some steps, and those steps are defined in the Jenkins file. So no longer fiddling around in the Jenkins interface to create stuff like this, simply use the Jenkins file. And so let's do that. New pipeline, give it a name, pipeline, doesn't matter too much for now. I could say, for instance, discard all builds, that it doesn't keep all build information, and I don't want concurrent builds because that's often a bit of an issue with timing issues. And I select where it can find the Jenkins file, and I will add the Jenkins file to my Git repository. So I simply supply my Git repository, and there it can find the pipeline script after I make it in a few seconds. So I save this. Pipeline is already done. Yeah, I also have to still configure GitLab so that if I do a push to GitLab, it will automatically trigger Jenkins with a webhook. So to do that, I have to do two things, and one is really something you need to remember because it's quite annoying. In the settings, we have to configure the network preferences that outbound requests should be allowed. Else it doesn't work. If you have an old version of GitLab, this wasn't necessary. This was introduced in one of the newer versions, and I didn't know about it, and it cost me like, I don't know, an hour before I found out that I had to enable this, which is a bit strange, of course, because now in my project, I say that I want to enable webhooks. So I was in the assumption that if I say I want to use them, it would be open by default. But apparently it requires an extra step. Again, for now, I don't care too much about security, so I add the webhook. And the webhook points to the pipeline that I created inside of Jenkins. And so last step is to create a Jenkins file. One thing to keep in mind is make sure that you give it the right name, so not jenkinsfile.txt or something like that. It should really be called Jenkins file. And you simply add it in the root of your project. And here, so I specify that I want to use Java 11 instead of Java 8, so I can compile code that contains Java 11 features. And I have a really simple first step to Maven package the stuff to get something going. So I push this to my Git repository. Of course, you should pick a really meaningful name, but for now, we just pick something easy. I push everything. So now the code is pushed to GitLab, and if everything goes according to plan, it will trigger a Jenkins job. So we see the first Jenkins job running here. It's still pending, so it will download all the artifacts it needs and all the stuff that it needs, and then after a while it is finished, but let's not wait too long for that. We will see that in a minute. So basically we now have steps 1, 2, and we have the Jenkins configuration, so now it's on to SonarQube to check for the code quality of my application. So SonarQube, I can simply follow the tutorial. So I simply log in, and I can generate a token, and the token is used to connect to the SonarQube instance. So I use this token to connect from Jenkins to SonarQube. I of course have to copy it without forgetting it. And I can simply finish the tutorial, and then I copy this in my Jenkins file. And let's see what other steps we needed to do. We have to do a few things. So we specify the login token, and we specify some new stages. So back in the day when SonarQube was really tied to Java, you could run one command and SonarQube would analyze everything. Nowadays you first have to run the tests and then feed Docker with the result of those tests. So it's now a two-step execution. Let's copy this over here. So I can define environment settings, that's basically variables that I can use. So SonarQube login token is then used within my instructions. And so I run the unit tests, and then I do a SonarQube analysis, and then I'm good to go. So let's see. Oh, I should, of course, commit and push my changes. So it's pushed. So let's have a quick look back at Jenkins. So my first job, it succeeded. It created a Maven package. So now a second job is running, which will create, again, a package, but it will also execute the unit tests and will create a SonarQube project. But we'll see the results in a minute, because else I have to wait for it, and I'm too lazy for that. Next step. I don't know if you ever used basically Jenkins or another Java tool with the Maven release plugin. So Maven release plugin is often used to make a relation between the source code and the resulting artifact. So if you have a production bug on version 1.2, you know which version of the source code you have to retrieve and change in order to fix the bug. If you do that with the Maven release plugin, it basically creates a tag inside your Git history with the version that's released based on that commit. With Jenkins, that's a bit tricky if you use the webhooks, because if I create a tag inside Git, it will trigger a new build of Jenkins, because every change in Git will trigger a new build. And that's basically an endless process, because a new build triggers a new version, and it triggers a new build again. With normal Jenkins, you could work around it. With Jenkins files, at the moment that I used it, I couldn't work around it. And I, in fact, find it a bit of a nasty feature as well, because your Git history is basically polluted with all kinds of tags. So instead of storing the version of the artifact in the Git repository, I store the commit hash in the artifact name. So that way I know which version relates to which commit hash. I've seen people that use, for instance, timestamps instead of it, but I prefer to use commit hashes. So to do that, we have to do a bit of configuration. At first, I'm going to remove the snapshots, because we only want to have normal releases. And in the build, I'm going to specify that I want to have the git commit ID as part of the name. So the name of my artifact will be the name of the application, dash my version, dash my commit ID. And you can basically make anything out of it if you prefer something else. It's read in IntelliJ, but it works perfectly, so don't bother about that. Next step is that we use some plugins to retrieve basically the commit hash and put it in the name we're using. So these two plugins make sure that I retrieve the commit ID and I can use it. Oh, wait, I should enable auto import before I forget that. And now the last step, or the last step in the pom.xml is that we have to specify where we will release or where we will store our releases. And in this case, it's in the Nexus repository on my machine. So I can simply put that somewhere, for instance, here. So now if I release something, it will be sent to this Nexus repository. And finally, the last step, we of course have to change the Jenkins file so that it will upload my stuff to Nexus. So we add an extra stage, and we're good to go. Start a new build. Let's have a look, because my previous build is also finished, and I can see the SonarQube analysis was successful. So let's have a look here. I see my SonarQube project in here. So I can basically see if I have any vulnerabilities. There is one really serious code smell in here, and that's that my naming convention is not really correct according to the SonarQube rules. This is of course a bit of a silly thing. You can have lots of more interesting rules built into SonarQube. So what have we done until now? We've managed to do this code quality analysis, and we managed to store the artifact inside Nexus. So the next step would be to create Docker images based on our application, store the Docker image in a Docker registry, and then retrieve it from the Docker registry and start a container based on top of it. That sounds like a lot of work, but actually with a few Docker commands, that's relatively easy. First step we're going to do is we create a Docker file for our application. So basically our application will be packaged in a Docker image based on OpenJDK 11. So this is running on Java 11 as well. And it works a bit like the Jenkins file. You simply put a Docker file in the root of your application. Docker file. Yes, I want to add it. And then, of course, I have to add Docker to my Jenkins file. So I specified two variables this time. One variable is for the Docker registry, so where the Docker registry is running. And the other variable is the application port. So I start my application, and it will be accessible from my host on port 8110. So now, of course, it's a bit, for all the steps that you see, I fiddle around a bit, and most of the time the last step is to add something to the Jenkins file, an extra stage to execute it, so it goes for everything. If you add more features to your continuous delivery pipeline, you configure some stuff, add some stages to Jenkins, and you're good to go. And so let's first copy these stages, and then I'll explain about it. And we quickly do, of course, again, a push of my changes. And then we have a look at what's going on here. So I again retrieve the commit ID, because for the container or the image that I create for Docker, I also want to use the commit hash as a name for my image, so that I can uniquely relate it to my source code again, just like the artifacts that I stored in Nexus. Next step is creating a Docker image. So I build a Docker image, and then I push the Docker image to the Docker registry. And as you can see, I push basically two so-called tags to it. One tag is with the commit ID, and one is with latest. So if I want to deploy the latest version, I can simply deploy test app latest. If I want to roll back or something, I can say, OK, I want to run test app and then the commit hash for that version that I want to roll back. The next step, I stop my running container. So the first time, of course, there's no container running with my application. But after the first time, there is already a container. So I have to stop it. And then I start it again based on the application port, so to make sure that I can reach it. And basically, this is the URL to my Docker registry. And here I configure which version I want to retrieve. At the end, I do a little trick basically to add the test app container to my Docker Compose network, so that I can connect to my container with test app port 8080 instead of using some IP address. So now everything is running in a Docker composed network and they can reach each other. So with Gatling, I can automatically execute tests against it without knowing my IP address or anything. Let's see, how far are we with building stuff? It's in fact already done. One thing I didn't show you yet is the Nexus repository. So here my jar files are stored. And we can see here, basically, so I didn't reset this, but you can see that every version will end up here. So it's a version number and a commit hash. You can also use an abbreviated commit hash if you want to basically have a bit of a shorter naming. Yes?
Johan, now that you're building Docker images, is Nexus still relevant?
Good question. So the question is, if you build Docker images, is Nexus still relevant? And I've had that discussion as well with some people. And my idea is that it's not directly necessary because you could retrieve the version from your Docker image if you want. But it's a bit more work, and a lot of organizations are still used to store artifacts in Nexus. And maybe you don't use Docker, then you can use everything up until now. But indeed, if you use Docker with a proper Docker registry, you might opt to skip Nexus or any other artifact repository. Yeah, you're right. Yes, so we have the versions inside Nexus. And we could also see in the continuous delivery pipeline that it is deployed to test. So let's see if the application is running. Localhost 8110, greeting. And again, oh wait, name is Rome. It's working, so if I do F5 a lot of times, I see that the counter goes up. So we have an application, it's deployed. So for now, we've basically created all of this. Up until step 6, we have a Docker container. Inside the Docker container, Tomcat is running with a Spring boot application inside it. So for now, the last steps we have to do is to add Gatling to do the performance testing. Who of you already have experience with Gatling? Experience with JMeter? Yeah, so if you use JMeter, I can highly recommend to look into Gatling. It's much easier. And it automatically creates nice reports and everything. I've given a presentation like this at a company once, and I explained a bit about Gatling, and then somebody at the first row started crying almost. He was really like, And later I heard that he spent the last week fiddling with JMeter and creating reports out of the results. And with Gatling, you could do the same in just a few lines of code, as I will show you now. So for Gatling, we need some dependencies, also to create the nice charge that Gatling produces for us. So let's add the dependency here. And again, we have a plugin that will be executed from within our Jenkins file. So the Gatling Maven plugin. And we create a Gatling test. So let's copy this. And I'll explain in a second what it's doing. First, we need to create a directory for it. We do it in a special Scala directory under the test directory. So source test. We add a new folder, Scala, Gatling. We can even mark it as test if we want. We store it. And now we have an extra directory, and we create a basic simulation class, simulation.scala. Yes. Oh wait, I created a package basic simulation. Oh, it was a Java file, now I see it. Okay, so let's see. I think I now have a directory basic simulation, so let's fix that quickly. We remove this one. Okay. And now we're good to go. Basic simulation. And it's in Scala, and Scala is hard and everything, but it has a really nice DSL, which makes it quite easy to understand if you ask me. So what's going on here? I create a scenario, I provide it with a name, and then I say repeat 3 times. So this is basically just a loop. Within the loop, I will execute a request to this URL, so basically to my application, and I check if the return is an OK result, if the status code is 200. Between each request, I pause for 10 milliseconds, and then I execute the next request. I do that based on the number of users, in this case 1,000 users, and ramp users 1,000 during 20 seconds means after 0 seconds I have 0 users, after 10 seconds I have around 500 users, and after 20 seconds I have around 1,000 users. And all those 1,000 users will execute the loop 3 times. And in the end I assert if everything was successful, so if 100% of the requests was successful. So compare this to JMeter if you're used to JMeter. Now again, last step, adding some stages to our Jenkins file. And commit and push that. And so basically we say here that we want to execute the test phase of Gatling and that we want to use my class for the simulation. So basically, step 8, testing if the application is performing well. And so let's see how SonarQube is doing. It's executing the pipeline. One thing interesting is they have a new look and feel for the pipeline. They call it the Blue Ocean team, and the Blue Ocean team will become the default team for Jenkins. So everything will be transformed to the Blue Ocean look and feel, but for now they only transformed the pipelines. So if you click on Open Blue Ocean team, you see here the different builds that I had. I can click on them, I can see more details, which steps are there. I can see for the last one how it's running, it's uploading artifacts. I can click on it, or not. There it is. And then it will show the log of that part. And so basically, the steps we are seeing here, unit test with coverage, SonarQube analysis, upload artifacts, it's all stages that I defined in my Jenkins file. So I could put everything in one stage, works as well, but now I can easily see what's going on and how far I have evolved, and I can even see like how long certain stages take, and maybe optimize my pipeline. But for now, let's get back here. So it's running the performance analysis. So that takes a little while. And still, I mean, if you want to see the details, you could use the console output, for instance, to see everything that's going on. So here I can see how my performance test is going. I'm at 58%, 82%. So I could use just this output, but of course it's a lot nicer to use some more graphical output. For the Gatling plugin, for instance, I can see the mean response time in a trend, but of course I only did one analysis, so it's just one dot. If I do more analysis, I will see a nice graph of it, but this is still really basic. It's nicer to look at the individual results. So this is what Gatling generates if I do a performance test automatically. So I didn't create this. This is automatically being generated. If you're used to JMeter and parsing CSV files and making nice graphs out of it in Excel or something like that, you will really like this. I did a lot of JMeter in the past, but I love this. And so I can basically find out everything. They have all kinds of graphs, too much information to explain now, but to see some statistics, for instance, here, I can see what the mean response times were. It's 137 milliseconds. I have a few high max response times, maybe because something was loading just at that point in time, or users were still ramping up. I can see things like 99 percentile, which is used often in companies. So 99 percentile means 99% of the requests are executed within like 5,544 milliseconds. So if you use like a mean or a max, max has some high values often because there's always something impacting your max values. And 99 percentile averages it a bit out. So it basically is like an average between a mean and some max values. It gives you a nice impression on how your application is performing. So that's basically the performance test part. So with only a few lines of code, I had a performance test and I have too much data to process basically. And so basically we came full circle, developed an application, deployed the application, and we ran the performance test against the application. So are we done now? Basically, you're never done because it's continuous delivery. For me, one of the parts of continuous delivery is that you have to improve your continuous delivery pipeline all the time. So last year or so, we do a lot with mutation testing. Mutation testing automatically tests if your unit tests are good or not by changing the underlying code for you. I can highly recommend to do that. It's also in my instructions, but I don't have the time now to perform it, so you could follow my instructions to get it up and running in this pipeline. But those kinds of things, they pop up, and when there's something new and interesting which you can use, you can simply add it to your existing pipeline. So don't create a pipeline like, oh, it's done now. No, it's never done. It's like an application, it's never done. It's always some point to improve. And of course, I skipped largely on the security. Depends a bit, of course, on how your company is doing this, but most companies probably want a bit more security with SSL and stuff like that, but you can add that on this pipeline as well. One thing I didn't do is, if SonarQube would find any issues or if the performance test is not good enough, then still my application is deployed and it's simply running. So you probably want to break the build if issues are found. And you can easily, it requires like an extra step to make SonarQube inform Jenkins if there are any vulnerabilities. And then you can basically fail the build upon that result. So for me, continuous delivery is something that helps all of us. It helps developers because you get quick feedback on your code while you're still working on it. And you can then easily fix the issues. And you can become a better developer. So I've heard some people say like, yeah, we have to use SonarQube for my manager, or I have to have so much coverage and blah, blah, blah. But I mean, we want to be good developers, right? So why would I want to deliver rubbish code? And especially if you do it continuous delivery, it's not that I have a tester which is testing my code for 2 weeks after I'm done. It's automatically released. For the business, it's nice because they immediately see the value of the application. It is deployed, they can watch it, they can see, okay, it works well, or maybe we have to tune this part or this part. And your users can automatically use your application really quickly after you have developed a feature. So I'm not saying that you have to deploy like 1,000 times a day like Facebook and the other hip companies are doing. For a lot of companies that might be a bit too much, especially if you work with one team on one feature, might be a bit much to try to get to that stage. But at least deploy like once a week or once every 2 weeks so that you have a general deployment and make it structural. So do it like every Friday or every 2 weeks on Friday or something like that. It's not really rocket science. I mean, I could do it in, we still have 5 minutes left, so in 40 minutes. So it's basically, you have to get started with it and then improve your pipeline. So also, don't try to build it complete at once. So if you ask your manager, yeah, I want to build a pipeline, it will probably cost me a month or 6, and then we're done, then probably your manager will say, no, that's too expensive, we won't do that. But if you start simple, often you already have like a Git repository, simply add Jenkins as a next step and do some checks in Jenkins that might cost you a day or something like that, and then improve based upon that. So every month add a new feature or something like that. So that way continuously improve. If you want to follow the instructions, they're all in my GitHub account. So all the steps that I've shown you, they're in there. The Docker Compose file is in there, so you could basically build it yourself based on this information. We've got 5 minutes for questions, so are there any questions? Yes?
In a real world, for example, I have 1 million of customers, and they want to measure the performance. How can I do it? For example, I restore a database every time, use the same, which is better.
Yeah, the question is, if you have 1 million customers on your application, how do you measure the performance of your application? One of the ways is doing performance tests, but I could also make measurements on production. So I could log, for instance, for every REST endpoint that I call, I could log the duration that it took to execute that endpoint. So basically then I'm testing with live users. So my users are executing my performance test. And that, in fact, I think is the best measurement, because you can never create the same scenario as a customer is doing. Because sometimes a customer waits for a minute, sometimes he's clicking 10 times on the same button. It's really hard to make a good performance test scenario. And I'm not saying that you shouldn't do any performance tests yourself, but you should do both. So you performance test it yourself so you know or you think that it can handle the load of production, and then to get real-world statistics, you let your users test it. And I agree with you, to do it yourself is really hard, because you need an environment basically that's the same as production, with the same data, the same users, etc. Most companies don't want to do that. I've even been asked for a large company who said, like, yeah, just do it on production, the performance test. I said, yeah, you're crazy. I mean, I might break your complete machine. I don't know when it breaks, and I couldn't log into the server, so I couldn't see how much CPU or memory was being used. So I had no idea. And as soon as you see your performance results go up, then probably your machine is already gone. And still, they wanted me to perform it on a live machine during business hours. In the end, I said, okay, I do it, but I walk away. If something breaks, it's your problem. Because it messes up everything. Your database has database optimizations, they optimize on queries, and if then I'm going to send all kinds of queries to it which normal customers might not use, all the optimizations are gone basically. So it's really hard to do it good, yeah. Yeah, you're welcome. Any other questions? Yes?
Jenkins pipelines instead of GitLab pipelines?
Yeah, so the question is, why do I prefer Jenkins pipelines compared to GitLab pipelines? Actually, I can't say I prefer it because I never did it in GitLab. But the thing is, like, how many of you know Jenkins or worked with Jenkins? Okay, so most people know Jenkins. And it's easy to get to work with it, and it integrates with almost anything. And I've heard from some colleagues that they also did things with the GitLab pipelines, but not all the features of Jenkins and all the plugins are available there, if I understood it correctly. So might be helpful for your case, but if you need a lot of features, then maybe Jenkins is a better solution. And I mean, it's easy enough to set up, so that's the reason, yeah. So we're almost out of time, so I would say thank you all and have a good day.